Welcome to qnawire.
Hi there. In this question, we are looking at 4 molecular geometries, and we want to know about the bond angles. So on our first one, letter A, we have trigonoplanar. So what that means is we have our central atom, and it's attached to 3 other atoms or bonded to them, but all of these atoms lie in the same plane. So what we have here for a bond angle is we have a circle divided in thirds. Well, a circle is, of course, 100 or 360. If we divide that into thirds, we get a bond angle of 120 degrees for each of these angles. Remember, the bond angle is the angle between any 2 bonds in the structure. So 120 degrees would be the bond angle for trigonoplanar. For a tetrahedral, now we have a central atom with 4 atoms attached to it, making something that looks a little bit like a rocket type shape. These 4 bonded atoms are spread as far away from each other as possible on that central atom. So when we calculate the bond angle here, or talk about the bond angle, we don't really calculate it, but what it is for a tetrahedral is 109.5 degrees. So each of these bond angles in a tetrahedral would be 109.5. For letter C, we have an octahedral. So we have a central atom, we have 4 atoms coming out of the center and an atom up and an atom down. This is called an octahedral because there are 8 faces on this. But as we look at this, we see that each of these bond angles is actually a right angle. Therefore, each of these bond angles would be 90 degrees. And finally, for our last one, we have linear. Well, linear, of course, means a straight line. And we know that a straight line is 180 degrees. So bond angle here in a linear structure is 180 degrees. All right, that concludes this question. Thanks so much for watching, and I hope this was helpful.